Okay. Let me just see something here. All right. So now tell me about some things that we did yesterday. So let's do, let's start with number 7. All right. Yes.
Can you also do like E on number 6?
Oh, yeah. Okay. Thank you. Yeah, let's go ahead. So we got down to substitution here. All right, and I appreciate that very much. So now the measure of angle 1 plus the measure of angle 3, we did that a substitution. Yes.
I get that it's like 90 equals 90 because it equals the same thing, but why wouldn't it be like reflexive or symmetric?
Which one are you asking me about? What does reflexive or symmetric mean?
Like reflexive is when.
But listen to me. These two things equal the same thing. The
Yeah.
measure of angle 1 plus the measure of angle 3 equals 90.
Yeah, that's why I'm confused.
So listen to me. 90 degrees is right here.
Mhm.
So you're replacing what's equal to 90 there.
Okay.
Right? Not what does 90 equal? 90 equals angle 2 plus angle 3. You with me on that?
Yeah.
All right. Now, yeah, I don't. Does anybody want to tell me what D is, the reflexive property? Tell me.
I put angle 3 equals angle 3, but I was confused.
Yeah, I don't even like that myself. Right. I think from C to E, we could just say what? Yeah, I honestly I don't know what that is. All right. I'm glad you asked me that. That I'm not sure why you have to say something is equal to itself there. So we can just say E is just the what? Yeah, subtraction property of equality. And then from there, we can say, what's F? Thank you. Very good. Definition of congruence. Now, Maren, did you understand what I said up here about 90 equals 90? So those two things are equal. That's a simple substitution is what we say. Okay.
Yeah. What's the difference? Like, why do you subtract between equals and congruent?
We talked about that. Again, it's just a technicality. Okay. Something measures are equal. They're asking me to prove that they're congruent. So if something is equal, then if the measure is equal, the angle is congruent. If the measure is equal, the angle is congruent. All right. Everybody okay with that now? Yeah, I'm not sure what D is. I think that's, I don't know what that is. All right, totally unnecessary. All right, so now let's take a look at number 7. All right, so the only thing we know for sure is angle 4 is congruent to angle 7, right? And that's 1. And then we can just say that's what? And that's given. Oh my goodness. All right. angle 4 is congruent to angle 7, and that's given. Okay, so now we're going to mark it. 4 is congruent to 7. All right, someone else want to tell me something here? Tell me.
Aren't 5 and 6 congruent too?
Why is that?
It's like, isn't that, it's like a theorem, I forgot what it's called.
Supplements of congruent angles are congruent, but those aren't supplements. Tell me.
4 and 5 are congruent because the right angle.
Yes. Angle 4 is congruent to angle 5. We just say that. Vertical angle theorem. So now what?
Angle 6 and angle 7 are congruent.
Yeah, angle 6 is congruent to angle 7, if you want to say that. Same, vertical angle theorem. I just don't think that's that difficult. So now what? Say it.
Angle 5 and angle 6 are congruent,
That's correct. Why is that?
substitution.
Yep. Anybody having trouble seeing that?
Why is the substitution?
What would you want it to be?
I don't know, I don't know why it would be substitution.
Watch. What is angle 4 congruent to?
7 and 5.
Okay, it already says in 1, angle 4 is congruent to 7.
Mhm.
So now angle 4, I'm going to substitute in angle 5. And angle 7 is congruent to what?
Mm. Mm.
So I'm substituting that in.
Mhm.
All I'm doing is just replacing one equal for another equal.
Okay.
All right. So here we go. Did anybody have any questions with 8, 9, 10? Yes.
Number 10.
Angle 2 and angle 4. Wait a minute. Find the measure of each numbered angle. So I'm trying to find 2 and 4, right?
Mhm.
So angle 2 and angle 4 and angle 4 and angle 5 are supplementary, and angle 4 is 105. So if 4 is 105 degrees, then what's 5? 75 degrees, right? So that means angle 2 and 4 are supplementary. So that means 2 is what? Then 3 would have to be. Does that make sense now, James?
Yes, sir.
Okay. What?
You do number 9.
Angle 2 and 3 are complementary. Angle 1 is congruent to angle 4. Angle 2 is 28. So
Angle 3 is 62.
28. Angle 3 has to be 62. Do you agree? This angle right here has to be 90. This angle right here has to be 90, right?
Yep.
That's a good one. Somebody? What?
I think 1 and 4 both equal 45. Since they're supplementary to 2 and 3, and 2 and 3 equal 90. And then
2 and 3 are complementary. Yeah, that just means they add up to 90, right?
But don't.
So yes, that's good. So listen, that was very tricky to see. All right, so I want everybody to watch up here. How many degrees from here to here? 180, right? So that means if 2 and 3 add up to 90, what's true about 1 and 4? They have to add up to 90 also, right? Everybody good with that? Yes, thank you, Lucas. 45 degrees, that was very tricky. Anybody else? All right, here we go. Let's try to write this 2-column proof. Let's see if we're getting better. Angle ABC is a right angle. Prove that ABD and CBD are complementary. Does everybody agree that's kind of obvious, right? Does everybody agree? So step number 1. Angle ABC is a right angle. Given. Now, because it is a right angle, what does that mean? It equals 90 degrees, right? So this is how detailed they want you to be, all right? So that means angle ABC, I should say the measure of angle ABC is equal to what? 90 degrees. And why do you suppose that is? Definition of right angle. Agreed? A right angle has a measure of 90 degrees. Okay, now what can I say? Equals, let's say equals ABC first. Right, so that's good. So here we go. Angle ABD plus DBC equals angle ABC. What is that? Tell me, go ahead. Thank you very much. Angle addition postulate. So now what? Equals what? 90 degrees. And that's a what, Maren? No. Why does this equal 90? Substitution. And now why does angle ABD and angle CBD are complementary? Why is that true? Yes, so that's the definition of what? Complement. All right, definition of complementary. Yeah, that's not too bad. Two angles that add up to 90 degrees are complementary. All right, hopefully you're feeling a little better. Let's scroll down, see if there's something else. All right, everybody look at 15. Everybody should be able to get 1 point at least on the test.
Angle 5 is congruent to angle 6.
Angle 5 is congruent, is congruent to angle 6. We're going to call that given. Someone else help me. What's next? Tell us, Lucas.
5 and 4 supplementary.
Yes. Now, okay, so I don't mind you saying that, but I think the first thing you have to say is angle 4 and angle 5 form a linear pair. Okay, again, minor technicalities. And again, if you don't do it exactly the way I'm doing it on the test, it doesn't matter. All right, I understand what you're trying to say. It's hard starting out. All right, does everybody agree 4 and 5 form a linear pair? Right? So we would just say that's definition of linear pair. Okay. Definition of linear pair. So now, what could we say? Tell me. Yeah, absolutely. All right. Angle 4 and angle 5 equal 180 degrees. Definition of supplementary. So now what?
Angle 4 plus angle 6.
Yeah,
Substitution.
yep. Angle 4 plus angle 6 equals 180 degrees. Substitution. And then what? Yes, angle 4 and angle 6 are supplementary. And again, you could just tell me what. That's definition of what? Bless you, bless you, bless you. Definition of supplementary. All right. Bless you. Let's just jump. We don't have time to do everything, but let's look at 20. Let's look at 20. Refer to the Florida state flag at the right. Prove that the sum of the 4 angles measure is 360. Tell me. I'm okay with that. Let's do this though. Angle 1 and angle 2 form a what? Linear pair. And also we can say what? Angle what? 3 and 4 form a linear pair. Now, you know what? I think I said something wrong up here. This isn't definition of linear pair. Listen, guys, put this down. It's totally my fault. Go back up here. It's the linear pair postulate. All right, I said definition of linear pair. It's the linear pair postulate. All right. Linear pair postulates. All right, so now come back down here. Now I want you to say that angle 1 and 2 form a linear pair, 3 and 4 form a linear pair. So what is that called? Yeah, linear pair postulate. Go ahead.
So there's just no given for this one, since they're-
Well, I mean, it's part of the picture. That's a very good question. You with me? All right. So sometimes you're just going to have to come up with that.
Okay.
Right? If you would have said 1 and 4, 2 and 3, would it be the same thing? Be the same proof, right? Just you put it in a different order,
Okay.
right? What?
So do two angles of a linear pair always have 180?
Yeah. Right? All right, so now we can say that this is what I misspoke a minute ago. So now you can say angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. That's the definition of a linear pair. All right. Definition of linear pair. All right, so the linear pair postulate is just showing you that two angles that form a line, right, form a linear pair. All right, the definition of linear pair means that those two angles add up to 180 degrees. All right, so now what?
1 plus angle 2 equals angle 3 plus angle.
Nope. That's true, what you said. James.
1 plus angle 2 plus angle 3 plus angle 4 equals 360.
Yay, there you go. You see that, right? Right, so we would just say angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. And we just say that's what? Addition, property of equality. So that wasn't too bad. Yeah, if you want to sit back there, you can. If you want to be comfortable, I'd prefer that. Okay. And just pull up that chair and just grab a seat. What?
Why wouldn't number 3 be the angle addition postulate?
What? Remember, the angle addition postulate says that the two parts equal the whole, right? All I'm doing is adding 1, 2, 3, and 4 together. I'm just adding. All right, now I want to look at if two congruent angles form a linear pair, then they are right angles. Okay, so let's do that. Now, I don't know why I didn't put the statement and reason there for you. All right, so what's nice is this one up here. Just copy this and paste it down here, and then we're good. All right, so do we know obviously that's true, correct? Right, so let's just try to quickly prove it. All right, come on now. Remember this, what I'm talking about. I don't want to do the proof. I don't want to write it out. All right, I want you to try to write it out. It can be different than mine. All right, it can be different from mine. So Ben, what are we going to say?
You're gonna say 7 linear pair.
That actually is true, but there's something given.
Like congruent.
Yeah, do you agree with that?
Yeah,
I'm liking that. All right, so even if you do that out of order, would it matter?
no,
No, it doesn't matter, right? But I like to just start with what they give us. So you would say angle 1 is congruent to angle 2. And with that being said, we know that that is given. All right, now say it again. What'd you say?
oh, angle 7, angle 8 are linear pairs.
And angle 8 form a linear pair. And that's why?
Linear pair postulate.
Yeah, postulate, linear pair postulate. Okay. So now what does that mean? Let's let you finish it out. What does that mean?
If they add up to 1 equals
Yes, what does?
7 and 8.
Yeah, very nice. So you say angle 7 plus angle 8 equals 180 degrees. And now we can say that's just definition of linear pair. Okay, so now what? I don't know why I put 1 and 2 there, guys. Sorry. All right, now what?
Um, oh,
Why is that important?
yeah, the same.
So what do I do?
Angle 8 is equal to angle 7.
So what? So what's the next step is what I'm asking you. Harrison, tell him.
Angle 7 is equal to 90.
No. Tell him.
Angle 7, yeah, angle.
No. 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 You guys are jumping way ahead. I got to do step by step. Step by step by step. Lucas.
Maybe substitute the 7 with an 8.
Yeah, right. Or an 8 with a what?
7.
7. Does everybody agree? Correct? So angle 8 plus angle 8 equals to 180. That's what again? Substitution. So 2 times the measure, 2 times angle 8 equals what? 180, right? Now, believe it or not, they kind of call this a substitution. Why do they call it a substitution? Because angle 8 plus angle 8 can be substituted for 2 angle 8. We used to call it also simplifying, right? Angle 8 plus angle 8 is 2 angle 8s, right? So I don't care if you call it simplifying either, all right, if you forget, but that's kind of what they're saying is a substitution. So then what do we know about angle 8? It equals what? 90. Why? Well, but how did I get from 5 to 6? What did I do? Yeah, division property of equality. Everybody okay with that? Division property of equality. Okay, so if measure of angle 8 equals 90 degrees, then what's true?
7.
Angle 8 is a what? Angle 8 is a right angle. And that, of course, is the definition of right angle. And if angle 8 is a right angle, then what? Angle 7 is a right angle. And we can just do what again? Substitution. Okay, so in your head, that's what you've been doing, but you just never had to write that down. Does everybody agree with me? Again, some of you guys just said a little things, little inaccuracy. but it's not really that big of a deal. All right. And I know some of you are telling me I can do it great when you're doing it. I totally understand that also completely. What?
For number 8, why wouldn't it be definition of right angle?
Where does it say angle 7 is 9 degrees? Anywhere?
Never mind.
No, it doesn't. Okay. Okay. Listen, we got to move now. All right. I didn't do everything, but I did a lot. All right. Now, today, I think if I'm not mistaken, did I put 2.7 up there or did I just want you to? I think I posted it, right? Will you check Classroom to see if I posted it? Okay, good. Then take out a sheet of paper because I really don't think there's a lot of. I don't think there's a lot of new information today, which should be very nice. All right, which should be very nice. And here we go. Head your paper real quick. I got about 15 minutes. Section 2-7. It's going to be pages 172 to 175. Numbers 1 through 40, 48, 49, 55. Pages 172 to 175, numbers 1 through 40. Now, again, I am kind of being funny when I said you did learn this in 6th grade. All right. You learned the name of all of these angles. All right. All right, here we go. Let's get to work. All right. The more we do now, less you have tonight. All right. It seems like a lot, but most of it you already know. Okay. So here we go. So here are 2 lines, M and N. All right. T is called the transversal. Now, generally, the lines are going to be parallel. All right. Generally, the lines are going to be parallel, but this doesn't just apply to parallel lines. Okay. So what I want everybody to remember, corresponding angles are on the same side of the transversal. They're always on the same side of the transversal, and they're always either both above or both below the other 2 lines. So what am I saying? Please look up. Let's review. 2 corresponds to 6. 1 corresponds to what? 4 corresponds to what? 3 corresponds to what? Okay, that's good. All right. Now remember, on the right side, I used to say right and above, right and below, left and above, left and below. All right, those are corresponding. All right. Now we have alternate interior angles. So this right here is in the interior of the 2 lines. So interior angles would be 4, 3, 5, and 6, correct? Alternate interior angles would be 3 and what? 3 and 5. 3 and 5. They're on opposite sides of the transversal. Opposite sides of the transversal on the interior of the 2 lines. So 3 and 5, just listen. 3 and 5 are alternate interior angles. What else are alternate interior angles? 4 and 6. Alternating opposite sides. All right. Now there's an alternate interior and there's also a alternate exterior. So this is the exterior and this is the exterior. So what would be examples of the alternate exterior angles? 1 and 7, 2 and 8. So you have alternate exterior, alternate interior, and corresponding. All right. You also have same side interior, same side interior. All right. So again, you look to the interior and what angles are on the same side of the transversal. 4 and 5 and 3 and 6. All right. Now, there is no same side exterior for some strange reason. All right. But we could identify the same side exterior, 2 and 7, 1 and 8. I'm not sure why they don't have those. All right. I'm not sure why. All right. So again, we have alternate interior. Well, we discussed interior. Never really will I ask you just specifically interior. We have alternate interior, consecutive interior. We never really going to say exterior. We have alternate exterior and we have corresponding. And this is not the first time you've done it. All right. So with that being said, here we go. Number 1, everybody look at number 1, 2, 3, and 4. Of course, abbreviate. Of course, abbreviate. All right. Now, 1 and 8 are called what? Alternate exterior. Alternate exterior. Good. 2 and 4. Corresponding, right? They're above and to the right. Both angles are above and to the right. 3 and 6. Alternate interior. And 6 and 7. I just called them, listen, in some geometry books, they call them same side interior. Believe it or not, in my old geometry book, it's consecutive interior. All right. I just want to make that clear. It can be either one. All right. The new geometry books are calling them same side. All right. Consecutive interior is the same. Is everybody with me on this? All right. So 6 and 7 would be consecutive interior. All right. Now, believe it or not, that's all there is to this. All right. So if you can't identify those, you can't do the rest of the page. All right. What?
Wait, what was 2 and 4?
2 and 4 are corresponding angles. They're on the top and to the right. You can have top left, you can have bottom left, you can have bottom right. Those are the corresponding. All right. So just to make sure, 1 corresponds to what? 3. 2 corresponds to 6 corresponds to, and 5 corresponds to. There you have it. All right. That seems to be the one that throws kids off. All right.
You need to write like bottom right.
No, don't do that. I'm just saying that's how I learned it, right? If I was confused, corresponding had locations for me. All right. Everything else to me was kind of common sense. Okay. Now, this is the one that's always, and this is always the information that's on the SAT and the ACTs. All right. So this little bit of information. What looks to be true about angle 1 and angle 3? Yeah, they are corresponding angles. Corresponding angles of parallel lines are always equal. Bless you. Corresponding angles are always congruent if the lines are parallel. Does everybody hear me? If the lines are parallel, corresponding angles are congruent. All right, what looks to be true about alternate interior angles? Look at angle 2 and angle 6. They are also congruent. If the lines are parallel, alternate interior angles are congruent. Everybody look at the alternate exterior angles. What does that look to be? They look to be congruent. So basically, I told you in 6th grade, if the angles are obtuse, they are congruent. If they're acute, they're what? If you have an obtuse and an acute, they always add up to what? That's exactly correct. That's literally what we did in 6th grade. All right, in the geometry component. All right, that's what you had to do. All right, so this is nothing new. So if I said, what is the relationship between 7 and 5? What would that be? And so they are what? They are congruent. All right. So now I'm going to put measure of angle 1 is 94 degrees. I don't even care about the questions. Angle 1 is 94. So what's angle 7? 94. What is angle 3? What is angle 5? So what's angle 4? 86. What's angle 6? What's angle 2 and 8? That's how easy that is, guys. It's really, really simple. All right, really simple. Yes, sir.
Why do you put 95?
Just because I can't write and talk at the same time and listen to you. All right. Now notice everything is either what? Congruent or supplementary. Those are your options. If the lines are parallel, that's true. Obviously, if the lines are not parallel, none of that holds true. All right, so let's look over here. Measure of angle 4 is 101. So I'm coming over here, 101. So what's angle 2, guys? 101. What's angle 8? What's angle 6? What's angle 5? Everything else is what? That's easy. All right, I'm good with that. Okay, so I don't know why I put that there. Maybe I was thinking I was going to prove something. All right, look up here, please. What's the measure of angle X for number 12?
125.
Yeah, 125. Come on, everybody, speak, please. What's the measure of angle Y? 125 degrees. Now, how do we know that? Because that's the symbol for parallel. The little triangles on the line. All right, what?
How'd you know it was 125 degrees?
Well, what is these two angles add up to? So what's 180 minus 55? You're amazing. Perfect.
Wouldn't Y be, would Y and where the 55 is be corresponding with them?
Y and 55 are definitely not corresponding. Okay, look at 13. What's true about those two angles? They're equal. What are they called? Alternate exterior angles. Right now, again, I appreciate Lucas being back, guys, but if only one person is talking, it's not, I don't know if you know it. And if you're sitting there going, wow, this is easy. I do remember now from 6th grade, then I'm happy. All right, that's the way it should be. All right, but if you want to get better, you gotta try. You gotta tell me an answer. I don't care if it's wrong. You got to tell me something. All right. Does everybody agree that these two angles are equal? Because they are alternate exterior angles. So now we just say 104 equals X minus 10. Do I care to solve that? No, I don't care. I want you to know the relationship. All right. So now I'm looking at 14. All right. I'm a little annoyed sometimes because they should draw little arrows. So I'm going to draw them for you. They're referring to that angle and to that angle. All right. So what is true about those two angles? They are called alternate interior. Thank you. So what are they? Equal. So everybody's going to write 2x minus 15 equals x plus 55. And I don't care about solving that. All right. Mental math. Okay, now they're coming over here and just asking you about, all right. So because we have 2 minutes, let's go ahead and do 15 through 24. All right. Everybody look at 15. All right. So here's angle 4 and here's angle 9. What are those called? Corresponding. All right. Now let's look at 5 and 7. What are they? 5 and 7. consecutive interior. Thank you. All right. Now, listen, is anybody want to ask me a question? All I've done is hurry. Okay, part of that is because I don't think it's that difficult. All right. Anybody? Elise, you want to ask me a question? Good for you, Abigail. Can we go back to 9? Yes. What's wrong?
On the diagram, when you were like finding out the different values,
Right.
how come 4 and 3 are equal? Like,
4 and 3 are not equal. They add up to 180. True?
Yeah.
Does that make sense?
thank you.
All right, go, Maren. Okay, sorry about that, guys. I don't know why I thought the bell rang at 9:05. It rings at 9:04. Hey, listen, I am also going to post the review. All right, some of you have talked to me about, hey, you want to really study. So I finished up the review yesterday. I'll post it on Classroom, and then tomorrow we'll go over this a little bit, and then you're going to study in class, and then on Thursday I will go over the review with you. All right, good job today, guys. I appreciate it very much.